Chem 107 students, we're back for our third video in chapter 1. Now we're going to talk about some chemistry. So matter. Matter is anything that has mass. My glasses, my phone, my cup, my little Yoda jump drive all have atoms in them. They're all matter. Matter is composed of atoms. So basically everything that exists that has mass is matter, and it's made up of atoms. So this picture here is just kind of showing you a representation of how we model the different atoms and how they're bonded together. So that's just kind of a model of a molecule. There are 3 states of matter. You've probably heard this before: solids, liquids, and gases. In the solid state, the atoms are packed close together, touching, so they're very tight. They're in a rigid pattern and very organized, and they do vibrate in place. So some people think solid atoms don't move. That's not true. They do move. They just move in place. They vibrate in place. Now, liquid, the atoms are, again, close together and touching, but not so tightly packed. They are free to flow and roll around each other in the liquid state, which is why liquids can pour. Now, gas atoms are not touching. They're far apart, and there's a lot of empty space in between the atoms. So gas atoms are not touching. They're far apart with empty space, lots and lots of empty space, constantly moving until they hit other atoms. So I'm going to have these animations that I would normally show in class on Canvas. So make sure you watch all the videos. These videos will be listed under the Canvas Chapter 1 videos as well. Same place where you got this video. So make sure you watch all your videos. All right, let's talk a little more about solids. Solids have a fixed shape and volume. So this little Yoda here has his own shape and his own volume. It's a solid. The solid atoms, again, vibrate in place in a fixed pattern. Solids can be crystalline, so pretty, or non-crystalline. Most are non-crystalline. Solids are not compressible. Okay, I can't smush my Yoda. Okay, I can push on it, but it's not going to compress. The particles are as close together as they can be already. Most solids are a little bit more dense than their liquid. So when you make ice cubes of something in the solid state, they would sink in their liquid. Ice is an exception. So water is weird. So when we make ice cubes and put them in water, they don't sink. They actually float. And that's weird. Most things you make ice cubes, they would sink. But for water, the ice, the solid state, is actually a little less dense than the liquid state. And again, that's not normal. So ice floats in water, and that's weird. So water is weird. It's not a typical liquid. Most liquid ice cubes sink. Solids do not mix by diffusion or osmosis. All right, liquids. Liquids take the shape of their container, but they do have a constant volume. If I have 2 cups of liquid in here, I can pour it into a stove pan and it would still be 2 cups of liquid. I could pour it on the floor and it would still be 2 cups of liquid, but it takes the shape of its container. Different liquids flow at different rates. That's called viscosity. So, like lotion, that pours real slowly compared to water or vodka. Liquids are not compressible either. So if you try to smush them, they're not compressible because the atoms are already touching. So you can't get them that much closer together. Liquids have a much higher density than gases do. Gases aren't dense at all because of all the empty space. Soluble liquids can mix together. So like orange juice and vodka mix together. They're soluble. Properties of gases. Gases don't have their own shape. They take the shape of their container. Gases don't have their own volume either. They can expand and compress. You can take a gas and smush it or expand it. It just means if we smush it, the atoms get closer together. If we expand a gas, the atoms get farther apart. So gases don't have their own volume. They don't have their own shape. Gases have a low density. Air is about 0.001 gram per milliliter. Gases mix completely with other gases. So if you spray some room freshener in a room, it'll spread throughout the room. They mix together. Remember, air is a mixture of hundreds of gases, but most of it is nitrogen, 78%, then oxygen at 21%, with the remaining 1% being CO2, CO, and all the noble gases and all the pollutants and everything else. Gases exert pressure, so they hit the sides of their container and exert a force. That's called pressure. So let's answer some questions now. Solids, do they have their own shape? Yes, they do. Good job. Solids, do they have their own fixed volume? Yes, they do. Okay, liquids. Do liquids have their own shape? No, they take the shape of their container. Do liquids have a fixed volume? Yes, 2 cups in the can. If I pour it on the floor, it's still 2 cups. Liquids do have a fixed volume. Gases. Do gases have their own shape? No, they take the shape of their container, like they fill up the whole room, so they take the shape of the room. Do gases have a fixed volume? No, they can be compressed and expanded. Good job. All right, next up is physical and chemical properties. Physical properties describe the appearance of a chemical and maybe some facts about that chemical, like the color, odor, taste, texture, melting point, whether it's a solid, liquid, or gas, so its state of matter, physical state, how dense it is it soluble, does it conduct electricity, how hard is it? So some physical properties would be, this is hot pink. It looks metallic. It is smooth. It has no smell. I'm not going to taste it. It's a solid. It is hard. And because it's metal, it would conduct electricity. So those are all physical properties. Chemical properties describes how a chemical behaves. So this needs to be like an action verb. Explosive, corrosive, toxic, reactive, rusts, oxidizes, decomposes, or if it does nothing, it's inert. So this is pretty inert. It doesn't do much of anything, right? It's not an explosive. It's not a toxic chemical. It's not a medicine. It doesn't react against my skin. So it's pretty inert, this metal container. So chemical properties need to describe behavior. Physical properties describe appearance and some facts about the chemical. All right, we're going to stop here and we'll deal with the physical changes in our next video. All right, bye-bye, Kim 107.